Hey, I'm Kathy McKeown, professor of computer science here at Columbia, and I am introducing Dilek Hakkani-Tür, our next speaker. Dilek is a professor of computer science at the University of Illinois, Urbana-Champaign, and she joined the University of Illinois just in the past year. Her research focuses on conversational AI, natural language and speech processing, spoken dialogue systems, and machine learning for language processing. She has over 80 patents and has co-authored more than 300 papers. She's also had a lot of impact in industry. So before joining UIUC, she worked as a senior principal scientist at Amazon Alexa, where she focused on enabling natural dialogues with machines. And before that, she was leading a dialogue research team at Google Research. And I'm not going to go further back, but she has had more impact at other companies as well. She's a contributor to the field. She served as associate editor for IEEE Transactions on Audio, Speech, and Language Processing, and as the editor-in-chief of the IEEE ACM Transactions on Audio, Speech, and Language Processing. She served as an IEEE Distinguished Industry Speaker in 2021. She's a fellow of the IEEE and ISCA, which is one of the main international organizations for speech. So with that, Dilek.
Thank you very much, Kathy, for the kind introduction. Hi, everyone. As Kathy mentioned, my research passion lies in enabling conversational machines. So I'll be talking about that area. And I have been working in this field for a long time. Oops. And I haven't seen such exciting days before. Research and the dialogue field has attracted so much attention since the large language models and their success in generating natural-sounding responses. But there are now also several publicly available data sets to study conversations. There are several publicly available models, as Tatsu was also mentioning. And we now have methods that help us to reason and then to respond in more thoughtful ways. There are also hardware is cheaper and more available in comparison to earlier. I want to talk very briefly about dialogue systems and then jump directly into challenges for the future research. So conversational systems have been studied mainly in two types. On one hand are the task-oriented dialogue systems, which aim to complete users' tasks, such as buying movie tickets or getting information about certain topics. And these usually rely on some form of an API that can complete the task. This has been the historical approach. And on the other hand, more open domain social conversational systems, which aim to engage users in interactions and let them have engaging conversations. These would be looking information or talking about movies, discussing news topics, and so on. The state of the art for both of the types of dialogue systems lies on large language models these days. For task-oriented dialogue systems, basically, state-of-the-art methods get the user dialogue context, final user utterance. They merge these with the descriptions of the APIs and get some call to the API, which can be then issued to the API with the results and the dialogue context and possible policy rules for the application that are given back to the large language models. We get a response and play them to the user. So the language models are core. for these type of systems now. Similarly, for open domain dialogue systems, the conversation context is used to look up information that would be relevant to the context. These are presented to the language model in addition to the dialogue context and knowledge. And the language model is asked to generate a response which is presented to the user. However, there are still many remaining challenges for conversational systems, and I want to focus on two, which are listed at the bottom, but let me mention a few others also. Controlling language models is a challenging field, especially over a longer session of interaction is even harder and remains as an open topic. And this has implications for applications, for example, where you need to ask the user, you need to confirm with the user, for example, the credit card, the amount you are charging before directly going in and then charging it. Or imagine applications in the medical domain or education domain where you need to make a longer-term plan and then apply that longer-term plan over the course of conversations. Evaluation is yet another challenging topic. Human evaluation is costly, but it can also be subjective. There are several automated metrics that are out there, but they do not correlate well with the human evaluations. Personalization is yet another important topic. For any conversational system, the system should be able to adapt to specific users. And with large language models that are trained with broadly gathered data, this is not easily possible. And doing this adaptation in a privacy-preserving way is quite a challenging problem. But the thing that I want to focus today is the factual accuracy. That's the first one. Basically, we all by now know that the large language models hallucinate or they actually generate responses that are incorrect but sound plausible. And this becomes even more severe in applications. For example, hallucination rates of 8 to 15% have been reported for enterprise domain applications, which could be quite dangerous. And on the right, I do have some example about my own background. In addition to answering more than what I have asked for, it is full of incorrect information. But they sound very feasible. Even I thought, like, oh, is this true? It can't be possible. So such hallucination is not acceptable. It's very dangerous. It's not good for real-world applications or generated speech. So people have been looking into retrieval augmented generation. And this mainly aims to retrieve knowledge and then ground the responses on that knowledge. There have been multiple corpora proposed to study this field, including Topical Chat that we released, but Wizard of Wikipedia, Wizard of Internet, and many others. And knowledge ingestion is also useful for other types of conversational systems, for example, task-oriented dialogues, because at any point in an interaction, the user may ask for knowledge that you can easily find on the web, and you should be able to integrate it into the conversation. However, knowledge is dynamic and can come from a diverse set of resources. And imagine knowledge graphs or databases that are more structured resources. Knowledge can be in articles or books, unstructured text, basically. It can be in subjective resources, such as customer reviews and so on. And the content may be spread over long documents or multiple resources. On the right, I do have some example interaction, just to show the diversity of the required knowledge. Imagine a user asking for things to do after the sessions at a conference before dinner. To be able to respond to requests like this, a conversational system should be able to have access and interpret users' calendar, extract times, locations, and so on. It should be able to interact with other knowledge, structured knowledge resources to be able to figure out what is nearby. It should be able to look at the web, try to personalize what it gathers from there so that it suggests this user the right information. And it should have access to maps and so on. It keeps going on to be able to come up with a response. And previous literature has studied augmented language models for this purpose. There is also a lot of recent work around web agents trying to gather information from the web and web forms and so on to be able to come up with responses to the users. And in our previous work, we basically looked into these diverse types of knowledge sources. Hopefully, it will become clear in a little while that you need to be able to deal with different types of knowledge. Retrieval just by itself may not be enough to integrate knowledge into interactions. So, for example, people may be asking things that you could find in structured resources, knowledge graphs, and databases. You would need to convert the user utterances or the dialogue context to queries to these structured resources. We and others have found that you can actually use the syntax of those query languages to improve the responses from the system. Or you can train models to enable the models learn about what is expected given such a context, and so on. Once the results are retrieved, then you can generate a response to the users. Other types of knowledge include knowledge spread in long documents. So these days, the large language models can consume very long context. However, because of the recency bias, usually they pay most attention to the things that they have seen the latest. But if information is spread over a long document, is it the right way to represent that document as a sequence, was the question that we were asking. We basically looked into natural language, using natural language processing methods to represent long documents or multiple documents in the form of graphs. And that way, you can try to bring things that are related to each other closer in the graph, and you can select a region from a graph instead of retrieving multiple documents, and use that to come up with a response to the user. And we have seen that this approach actually performs more reliably in comparison. And subjective knowledge is another one, because oftentimes users ask things where you can find the knowledge in customer reviews. And we all do this, right? We look up for the things that we select, whether the reviews suggest them or not. However, there aren't very many resources to study this area, because even bringing together a review corpus is quite challenging due to copyright issues. So we have collected large review data sets, and then we have collected conversations that include responses using those reviews. And we have proposed benchmarks where a lot of other teams can study how to integrate responses from subjective sources into conversations. We also built baselines where we modeled this problem as, let's first detect which terms require subjective information, track entities over the courses of conversations so that we can retrieve the reviews related to those entities. We looked into knowledge selection methods, basically based on classification to locate those sentences that are specifically related to the aspect that the user is talking about. And then aspect-based sentiment analysis to group things about this aspect, to group things based on their sentiments. And finally, response generation. And last but not the least is the common sense knowledge. So common sense is important. It's the implicit information that we share. It's not explicitly seen in conversations. So to be able to study this area, we actually looked into public corpora and annotated them with common sense reasoning steps based on the common sense knowledge graphs that are available out there, such as ConceptNet, Atomic, and so on. And with these reasoning steps, we trained the models to reason about these commonsensical knowledge so that the responses they generate are more acceptable. And this would imply, for example, if you want to buy flowers for your wife, the rose is type of a flower, it could be a symbol of love, and so on, the commonsensical knowledge. And then the response is based on what the model has learned to reason about. And let me now move to response safety. So we know the models can generate biased and toxic outputs. And unsafe responses in conversations are simply not acceptable. They can be harmful to the society, individuals, entities, companies, and so on. There is a lot of work on detecting biased or unsafe content in text. So, for example, you can use these classifiers to filter the unsafe examples from the training data and then try and train more safer models. There is work that uses these classifiers on the inputs and outputs of the models to apply appropriate filtering methods. There is work that has actually tried to remove or detect and remove bias during the generation, token by token. As tokens are generated, the models try to assess whether the sequence that has been generated so far is biased or not. And finally, there has been a lot of work on reinforcement learning from human feedback. I do apologize, the next 2 slides include some offensive examples so that I can make my point. So now that the language models are capturing bias and they can actually perform many tasks, we did one analysis. Are they actually also capturing or are they able to remove the bias themselves? Can we use them to improve themselves? And we define this as a set of tasks. Given the input text generated by the model, we ask the model, is there bias in this text? Can you identify the type of bias that is in the text? It could be political affiliation, gender, ethnicity, and so on. And can you extract the subsequence in the input that introduces the bias? And can you remove that bias by rephrasing those sequences? And we have tried 3 broad classes of task descriptions. We formulated these as statements, questions, and sentence completion. And we have seen that LLMs can indeed perform some of these tasks, but unfortunately only to varying degrees, so they are not perfect. For this purpose of bias removal, we have also looked into other methods, such as in-context learning, which retrieves examples that are similar to the current conversation context, but they would include safe responses. And providing these safe responses improves the response of the language models also. For this purpose, we have used data sets with safe demonstrations that are already available out there, and have seen that actually this form of in-context learning can improve the degree of bias that is in the generated outputs. And as these methods perform as good as pre-training or fine-tuning, the important thing here is when somebody discovers a biased sequence or a bad toxic output from these models, these days, usually people announce it, and then a lot of other people try, and then the toxicity spreads even further. So this form of methods can quickly recover from these issues because you can always write safe demonstrations, additional safe demonstrations. You don't have to wait until a new model is trained and stop the spread of bad information at that time. So let me conclude. As I mentioned, very exciting days for conversations due to several advancements. And however, we still have several challenges ahead. Some of the future work or current work that we and others have, looking into unifying approaches for digesting different types of knowledge. Trying to model the accountability of the models so that we can try and learn policies, dialogue policies, that would prevent AI over-reliance to the model outputs. And for bias elimination, we and others are looking into how can we improve these models offline through multi-agent conversations so they try to trigger bias on each other and then try to improve over that bias. Thank you very much for your attention and looking forward to the discussion.
So thanks, Dilek, for that talk. There are a lot of really interesting and challenging problems there. I'll start off. You were talking about the problem of factuality in what models produce. So this is when models generate things that are not true. And you talked about using methods that instead of just relying on the language model, retrieve knowledge from the web. And so my question centers on truth. What is truth? How do we know where to find it? And how can we use it?
Fantastic question, Kathy. For applications that are maybe for task-oriented domains, usually you get databases, you get APIs, you get maybe documents that are describing the domain, and they are useful. But I've been thinking about this, like especially as we go towards the web, towards more open domain. And in my opinion, the problem is almost similar with web search. With web search, we also get, we search for something, we also get some information, and the responsibility lies on us. But then we do know where we are getting the information from, and we have developed some form of trust maybe on those resources. Whereas in these new modeling approaches, we don't know where the information is coming from or how confident the model is, how to present the confidence of the model to the user, and maybe use how to use attribution so that the user knows where the knowledge is coming from. I think these are all important areas. It's possible. The question in my mind is how to do this, because in conversational speech, for example, if we try to list all the URLs and the confidence, probably we would lose the interactors at that point. They would find it boring. But there needs to be, I think we need to think more carefully about how to make these things visible to the user so that even if the responsibility lies on their shoulders, at least they do have enough information or visibility into where the responses are coming from.
Okay, so can you say a bit about attribution? So I think even if we were thinking of like a written conversation with ChatGPT, for example, and we see text that's generated, but unlike in a search, we don't see where it's drawn from. Is that ability possible now within a large language model? And yeah, how would you use it?
I think with retrieval augmented methods, for example, it would be possible to provide pointers to where the knowledge comes from. It could be possible, there are some recent studies on trying to estimate the confidence of the system. There are approaches that do explain in more detail, though that one is a little bit tricky because explanations also increase the over-reliance. So there has been some studies, not in dialogue domains, but other domains, that if AI comes up with explanations, that could be even more confusing the users and then making them over-rely on the system output. But it could be possible maybe with some form of confidence and attribution.
Okay. Yeah. So let me ask about, when you were talking about retrieving two other problems that I think of. One is the fact that there can be contradictions. So if you're retrieving from, let's say, scientific journals or even news articles, they can report things that are different. And we also have this upcoming problem with the web will include much of what will be on the web will be generated by AI. And what do you do about that?
Yes, and that form of contradiction problem was actually acute in the case of reviews, customer reviews, because people may have confusing opinions. We did work with designers on that problem, and the conclusion was basically representing all views, summarizing and representing all views. But it's a different problem for factual knowledge, right? You need to be able to detect which one is reliable, which one is the information that you need to present to the user. So I think retrieval alone is not sufficient. We need to do more. We need to assess the reliability of these resources online so that and then figure out which one is the most reliable, which basically has the accurate information, and then use those.
Yeah. Great. All right, so I'm going to turn to some questions from the audience. Let's see. What is the ideal role of the conversational AI? A well-educated scholar, a rational advisor, or an empathetic friend? Should users have the right to reshape the characteristics of large language models?
Fantastic question. I think all. I think users should be able to shape, in my opinion, because we all have different preferences. Not necessarily for chatting purposes, but an actual agent that is going to be useful for me to achieve things should be able to learn what I prefer or how I like to communicate and so on. But these are all challenging questions, and also there could be some other implications, which unfortunately is not in my area, but there could be other implications regarding creating ill-intended engines and so on. So it could also be tricky.
All right, another one. Common sense reasoning models that are pre-existing tend to focus on single sentence statements and concepts. In conversation, the way common sense presents itself can be more subtle through pragmatics or local customs. How do you suggest we can develop common sense reasoning more suitable for dialogue purposes?
So that's a good question. That's something that we have looked for some time also. We decided not to go with single sentences, but more like graph form representations that the literature has already also been using, and then try to figure out what portion of the graph basically needs to be invoked, not just single transition, but a subgraph. And then that could be used for generating better responses, because oftentimes it's not just one single information. But that said, it's quite a challenging topic, especially because there is some work demonstrating these large language models do already capture some of these common sense reasoning steps, but not all. So we thought if we ask the model to explicitly spell out, or if we train the model to explicitly spell out what it has been thinking, we could better understand the problem, and then if needed, we could probably provide information to the users as well. But it's a very challenging area, so I think we are only scratching the surface, not really solving the problem yet.
Okay, another question from the audience. You used an example of bias that every reasonable person would consider as bias. But what about controversial issues that some consider as bias and others don't? Is there risk of censorship here?
It is. There is. And usually things that may sound biased to some populations may not be biased for others, and so on. It's a very tricky topic. And these days, when we are evaluating bias, usually now the evaluations are using not just single annotator, but a group of diverse people to assess this bias. But it would be interesting to apply this with the modeling approaches also. I'm not aware of any recent work in this area, so it's clearly a problem. Mm-hmm.
Okay, and I'll close with one last question. So in your talk, you discussed two problems, factuality and safety in responses, and you gave some direction that you're working on to address them. I wonder if you could say which of these two problems you think is harder, perhaps more serious to address, and how close we are to solving them.
It's very hard to choose one over the other. I think they are equally important for different reasons, but equally important. Are we close to solving them? Maybe for simple cases, yes, or maybe for knowledge, maybe a little bit more than bias. But I think much more work needs to be done to make these systems much more reliable accurate, trustable, and so on. Yeah.
Okay, great. Thank you.
Thanks.